You have been writing Python classes for episodes. But have you ever asked who built a class? When Python executes class dog::pass, it does not just store the definition. It calls type, passing the name dog, an empty tuple of base classes and the class body as a dictionary. And type returns a brand new class object. I am Ahaz. Today in episode 28, Metaclasses, you will learn the mechanism Python uses to build every single class in your codebase, and how you can replace or extend it. We will cover type of dog, which reveals the metaclass behind your class, type called with 3 arguments to create classes dynamically at runtime, writing a custom metaclass by subclassing type and overriding done or new, the 5-step class creation pipeline, from the class keyword to the finished class object, done or init_subclass, which gives you 90% of metaclass power with none of the complexity, and the decision rule for when to use each. We finish with a mini project, an auto-validating ORM-based class built entirely from these tools. Let's go. The first thing most Python developers never check: what is the type of a class? Look at the code. Type of X, where X equals 42, returns int, expected. Type of Rex, where Rex is a dog instance, returns dog, also expected. Now watch what happens when we call type on dog itself. Type of dog returns type. Not dog, not object, type. The same is true for the built-in classes. Type of int returns type. Type of str returns type. And if you push one level further, type of type returns type. It is self-referential, and it is intentional. Type is the metaclass, the class whose instances are classes. When you write class dog::, Python is using type as the factory that construct dog. Type is not just the function you call to check a values class. It is the engine that builds every class in Python. Type has a second form, with 3 arguments that most developers never use, but that Python itself uses constantly. Type of name, bases, namespace creates and returns a new class object. Look at the code. On lines 5 through 7, we define animal using the class statement, the familiar way. On lines 10 through 15, we do exactly the same thing by calling type directly. The first argument is the string animal, the class name. The second is a tuple of base classes, here, just object. The third is a dictionary containing everything the class body defined, the sound attribute and the speak method. Both forms produce identical class objects. Python uses this 3-argument form internally every single time you write a class statement. The class keyword is syntactic sugar. Understanding this is what makes metaclasses approachable. A metaclass is simply a class that intercepts this type call and does something with the arguments before the class is built. Now let's write a real metaclass. A metaclass is a class that inherits from type and overrides done or new. Look at the code. UpperMeta inherits from type. Its done or new receives 4 arguments: MCS, the metaclass itself, name, the class name string, bases, the tuple of base classes, and namespace, the dictionary of everything the class body defined. We create a new empty dictionary called upper_ns. We loop through the namespace, and for every key that does not start with double_, meaning it is not a dunder method, we convert the key to uppercase. Then we call super_dunder_new with the rewritten namespace, which builds and returns the finished class. Now when we define API with metaclass equals UpperMeta, every method name is automatically uppercased. Get_user becomes get_user. Post_data becomes post_data. We transformed the entire class namespace before it was built, without touching the API class at all. Let's make the class creation pipeline concrete. When Python sees the class keyword, 5 steps happen in order. Step 1. Python parses the class body as an indented block. Step 2. Python determines which metaclass to use. It checks the metaclass keyword argument first, then looks at the base classes, then defaults to type if nothing else is found. Step 3. Python calls the metaclass's done_prepare method to create the namespace dictionary. By default, this is just an empty dict, but you can override done_prepare to use an ordered dict or custom mapping. Step 4. Python executes the class body inside the namespace dict produced in Step 3. Every assignment and def inside the class body populates that dictionary. Step 5. Python calls the metaclass with name, bases, and the now populated namespace. This is where done_new runs. The return value is the finished class object. Understanding this pipeline tells you exactly where a metaclass can intervene and at which step. For most practical use cases, you do not need a full metaclass at all. Python 3.6 added $init_subclass, a class method that runs automatically every time a subclass of your class is defined. Look at the code. Plugin defines a class-level registry dictionary. Then it defines $init_subclass as a class method that receives CLS, the new subclass, and any keyword arguments passed in the class definition. Inside, it registers the subclass in the plugin registry using the name keyword argument as the key. Now, when image plugin inherits from plugin with name equals image, Python automatically calls plugin $init_subclass, passing image plugin as CLS and image as name. The subclass is registered. No manual registration, no decorator, no metaclass. Plugin.registry now maps image to image plugin and audio to audio plugin automatically. This is the pattern Django, Pydantic, and SQL Alchemy use for their model registration. When should you write a metaclass versus using $init_subclass? Look at the two panels. On the left, a singleton metaclass. It overrides $call, which intercepts every time someone instantiates the class. This is something only a metaclass can do. $init_subclass runs at class definition time, not at instantiation time. On the right, a base class using $init_subclass. It marks every subclass at definition time. No metaclass machinery needed. The rule is simple. Use $init_subclass when you want to react to the creation of a subclass for registration, validation, or adding attributes to the subclass. Use a metaclass when you need to intercept $call to control instantiation, like a singleton or $prepare to control the namespace dictionary itself. If in doubt, start with $init_subclass. It is simpler, more readable, and sufficient for 90% of cases. Our mini project, an auto-validating ORM base class that combines everything from this episode. Look at the code. Model defines $init_subclass. When any subclass is defined, Python calls this method with a new subclass as CLS. We extract all annotated fields from CLS.annotations, a dictionary that Python populates from the type hints, and store them in CLS._fields. At instantiation, $init loops through every field. It gets the value passed in as a keyword argument, checks whether it is an instance of the declared type, and raises type error with a descriptive message if not. If the check passes, it sets the attribute on self. Now when we define user inheriting from model with name annotated as str and age as int, the field map is captured automatically. User of name equals Alice, age equals 30 passes validation. User of name equals 42, age equals old, raises type error immediately. No metaclass needed, just $init_subclass and $annotations working together. Your challenge: build two things from scratch. First, singleton meta. Write a metaclass that inherits from type and overrides $call so that every class using it can only ever have one instance. Test it with a config class. Two calls to config should return the same object. Second, extend the validated model from the mini project. Add a char field that takes a max_length argument and raises value error if the string is too long. Add an int field that takes min and max values and raises value error if the integer is out of range. Define a user model with 3 annotated fields and show both a valid and invalid instantiation. Paste your singleton meta and your user model with output in the comments. I read every single one. Let's recap what you learned today. Type of any class returns type, the metaclass that built it. Type called with name, bases, and namespace dict creates any class dynamically. This is what Python does internally for every class statement. A custom metaclass inherits from type and overrides dunder new to intercept and transform the class namespace before the class is built. The class creation pipeline has 5 steps: parse, find metaclass, dunder prepare, execute body, call metaclass. Dunder init_subclass runs automatically whenever a subclass is defined, giving you class creation hooks with no metaclass required. The decision rule: use dunder init_subclass for registration, validation, and attribute injection at class definition time. Use a metaclass only when you need dunder call or dunder prepare. The mini project built an auto-validating ORM-based class using dunder init_subclass and dunder annotations. Next episode: descriptors in dunder get and dunder set. The mechanism behind property, class method, and static method. Subscribe so you don't miss it. See you tomorrow. Metaclasses mastered. You now understand how Python builds every class and how to control it. Subscribe for the next episode. Drop your singleton meta or ORM model in the comments. I am Ahaz. See you in episode 29.